Hey gamers, welcome to my educational video about how I made a procedurally generated maze in Unreal Engine 4 using binary space partitioning. So procedural building has a few variables you can change. Floor width is the width of the whole maze and the length of it. Wall height is the height of the walls at the side here, and rooms per side is the number of rooms on each side, and room spacing is the space between the rooms. Obviously, if they go too close together, they'll just merge into a single room though. So maze corners is the number of openings in the corners. So you can see it's set to 4 right now by default. If I set it to 1, it'll just be this corner, 2 it'll be the diagonal corners here, then 3 will be this one, this one, this one. Now I'll change some values and we can regenerate this maze. So regenerate that. And there we go. So now we got a bigger maze. And there's only one corner on it, as you can see. And yeah, so now there's 12 rooms per side. So if you're wondering, yes, you can play the game now. Okay, so here we've got the opening for the maze. We can walk through and get lost in the maze. So taking a look at the header file for procedural building, you got all the default stuff, the tick function. Then down here we have should tick if viewports only, and that basically ensures that the tick function works in the editor and only in the editor for this class. BSP I don't think works during gameplay anyway, or during runtime. So you need this to be able to generate it. So then we have this view property, edit anywhere, which is the level map, the terrain that you saw earlier. It gets the center of this and positions the maze in the center of it. And then regenerate build is just the Boolean value. You click the checkbox and it regenerates the maze. And these are all edit anywhere, so you can change them in the editor. Down here we have a T-array of A-brush pointers called rooms, and this stores all the brushes, and this is for garbage collection and stuff. And then T-array of F vectors called valid positions. What it will be for is for spawning guns and objects, and the end goal inside the maze. That's my group member. He's working on procedural guns and procedural pickups and stuff like that. I commented this out, but this was going to be a static mesh, but it doesn't work. When I tried to use the function that they give you, it didn't work, so I'm not really sure what to do there. So I just left it. What generate geometry does is it generates the geometry, so it's pretty self-explanatory. Clear geometry just deletes everything. This is called when you want to regenerate the geometry. And then we have create brush, which returns an A brush pointer, and this generates the actual individual brushes. It has a few parameters, so the float width is the horizontal and depth scale of the room or of the brush, and the height is obviously the height of the brush. F vector position is where the brush is positioned, and then bool additive subtractive determines whether the brush is an additive one or a subtractive one. So a subtractive brush just takes chunks out of the block, and that's what I made the rooms with. So there's a main block that's spawned, and then all the rooms are cut out from that main block basically. Moving on to the CPP file. In the constructor there's all the initializing the defaults for the variables that generate the maze. In the tick function there's this if statement, so if the level map exists and if the regenerate build is true, is set to true in the editor, it will clear the geometry, it will regenerate the geometry, and it will set regenerate build back to false, so you can then continue to regenerate the maze. We've got generate geometry here. So first of all, the center point, which is an F vector, is defined, which is where the maze is spawned. It's based on the level map width times the grid size over 2. Float room width is the floor width divided by the number of rooms per side. And then the room gap is the room spacing times the room width. And that's the gap between each room. Float block width. Block width is basically the size of the main block of the maze plus an outer wall, because otherwise the maze would cut out all the sides. But the main block is created by setting, so the main block is set to whatever the create brush returns based on the block width, the wall height, position to the center point, and since it's true, it's an additive block. So as I said, it's the only additive one and the rest are subtractive. And then rooms dot set num is set to rooms per side times rooms per side, because it's just a 2D array flattened basically into a single dimensional array, just to make it kind of simpler. So then we have these for loops for each row of the maze and each column of the maze. First it stores a pointer to the room returned from create brush based on the room width, wall height, and then this positioning, which is kind of specific when you compare the scale of objects to the position. The actual size scale is like 100 times the size of the movement or location scale. So you have to like add times 100 times 50, etc. So then we have false here, which means it's a subtractive block. And then we set in the rooms array, we set k plus j times rooms per side to that room, and that's just to account for the fact that it's a single dimensional array, but it has to store two-dimensional values basically. This T array of brushes doors, which stores the doors in the whole maze. Then adjacent blocks stores the blocks that surround each room. Checked always holds the rooms that have already been checked around whatever room that it's working on. F vector midpoint stores the point between rooms so that you can connect the rooms. First room location and second room location is just the rooms that are being connected together, or the locations of them. Door exists stores whether a door exists in a certain spot, so that like if there were two rooms next to each other and one connects to the other, I didn't want the other one to try and connect back to the one that already connected to it, because that's redundant. For each room we set the first room location to the room's location. These if statements determine the adjacent rooms. Door num is a random integer between 1 and 2. Rooms can either have 1 or 2 doors. Check doorways is emptied while the door num is greater than 0, which means while there's still doors to add. If check doorways.num is the same as adjacent blocks, it breaks it, which means all the doorways have been checked. Otherwise, door to check is a random adjacent block. If check doorways does not contain the door being checked, then door exists equals false, which means there's no door there. And then second room location is set. If the rooms share the same y value, then the midpoint of the x values is found. Obviously the center point in the first room location is the same thing with if they share the x value, then it does the y midpoint. For each door, it checks if a door exists at the midpoint, and if a door exists, then it breaks out of this loop. Checked always adds the door that's been checked. If the door exists, then the number of doors to add is subtracted because there's already a door there. If the midpoint is not a zero vector, then again the door number is subtracted and a door is created. After the while loop, adjacent blocks is emptied so that each room can set its own adjacent blocks. And then down here we got rooms append, doors, and this is just for garbage collection. And this for loop gets all the positions of the rooms and the doorways and adds them to valid positions so they can be used for spawning stuff. And rooms.push main block, so for garbage collection as well. And then this float corner size is the size of the corner blocks, and then each corner is created. So if these if statements are based on the maze corner's value. I'll show you what this is. So this and this as well. This is supposed to convert all the brushes to a single mesh and save that mesh in wherever you want to store it. So here I've got game assets, meshes, building mesh. But unfortunately, when I tried it, it didn't work, and I couldn't find any documentation. There was like 3 pages on Google, and they didn't say anything useful. It still works otherwise. It's probably better for lighting and collisions to have it as a single static mesh. So then this last line, it rebuilds the level to accommodate for changes and additions of BSP brushes. Here we have clear geometry, which just destroys it. So it clears all the geometry. It empties the room's T array, so it could be added to again in the valid positions as well. Create brush has all these lines to create a brush. First you get the world, you spawn a brush, and it's not that simple. Then you get the brush builder and you set it to a new brush builder, and you set the brush to this brush variable which you just spawned, and then you initialize the brush, and then you set the brush type, which in this case is based on the additive subtractive variable. If it's true, it's a additive one. If it's false, it's a subtractive one. So it's just a simple Boolean statement. You get the brush builder and you build the brush to add in the world. Then set need rebuild just sets that the level has to be rebuilt because you've made changes to the level by adding BSP brushes or modifying them. And then these 2 lines just set the location and the size of the brush, and then the brush is returned, so you can do whatever. So for our project cohesion, basically we're making a stealth type shooter where you have to infiltrate the enemy base. In this case is the maze I've just generated. So we're adding on top of the enemy sensors and knowledge sharing, the hearing sensors that we added last time. We're adding this procedural maze, and also my group member is adding procedural weapons, and also I think weapon placement and stuff like that. And then in the final project, it's going to be an online demo where you have to basically get past the enemies, sneak past them without alerting them, and also go against your fellow man and try and reach the goal somewhere in the maze, randomly spawned in the maze somewhere, and be the first one to do that. If we do have respawning, we'll probably set a life counter to like 3 lives or something, and the game basically each round will be won if a player reaches the goal, and the first to 5 wins will win the whole game, or at least that's what I envision. So yeah, so that's our whole project so far, and that's what we plan to do. So thanks for watching.